In real world, most of the operating system may may not just use a single structure we have discussed in the previous slides. So they often combine multiple structures together to achieve the design goal there. For example, Linux and Unix, they put all the functionalities inside the kernel and load them into the main memory. But they also support the dynamic loading feature. So later, when the users wants to add some additional functionalities into the operating system, they can dynamically load them into the kernel or into the main memory. And also for Windows, the general structure is monolithic since it is very complicated, and the Windows operating system is the widely used business operating system. So the efficiency is the most important design goal there. And also, Windows allow the dynamic loaded module to be attached. So you may heard or see the extension .dll in Windows operating system, shortened for Dynamic Link Library, which is implemented for dynamic loaded modules. And in each subsystem of Windows, it tries to follow the microkernel structure to keep the essential functionalities inside the kernel. And all the non-essential functionalities will be put in the user mode. In this slide, show us the example of Mac OS, so which is the real-world example using layered structure. However, the layered approach is just partially applied. Here we have three layers. One is for user interface, one is for application environments and services, and the last one is for kernel. But beyond that, we cannot do further. So do you remember the example we have mentioned in the previous slide? The three main functionalities of operating system: the CPU scheduling, memory management, storage management. So the kernel is as a big chunk inside one layer. So inside the kernel, we have two cores. So one is a Mac, which is the real-world example using microkernel structure, and the other core is a Unix BSD. And also on the bottom of this layer, we have a kernel extensions. So it works like the module structures, as we already mentioned. And there, the additional functionalities can be dynamically loaded into the kernel by user. And in this sense, the module structure is also used by macOS. So therefore, the real-world operating systems more or less use multiple structures, as we have discussed in the previous couple of slides there. In the last part of this chapter, we are going to talk about the two operating systems which are used by mobile devices. And the first example is iOS. So since in mobile devices, there are more things to be handled and more devices to be delivered to the users. So that is why in mobile devices, so even more layers are divided there. And the lowest layer is a core operating system. It follows the structure of a Mac OS, and everything will be put there, but it will be customized for different mobile devices. So above the core operating system layer, so we have three other layers. On the top, we have a touch screen layer. So since most of the nowadays mobile devices, there's no physical input device such as a keyboard or mouse. So touch screen is the interface that user can interact with a mobile operating system. And the second layer is a media services, which is a very important service for mobile devices because nowadays people watch a lot of video through mobile devices. And also for mobile phones, one very important service is making phone calls. So since a lot of sensors are built inside the mobile devices, such as the cameras, GPS sensor, gyroscope sensor, and accelerometer sensor, etc. So for those sensors are abstract as services so that they can be accessed by operating system and also accessed by users. So therefore, we have a core service layer there to provide services to users. Another mobile operating system example is Android, which is another very popular mobile operating system. So different from iOS, Android is an open source operating system, which is based on Linux kernel. And also, it further extends the Linux kernel with battery management. So for desktop or even laptop, people they don't care about the battery very much. However, most of the mobile device users they care about the battery life a lot. So whether it can run a couple of hours or several days. And also there are different libraries to support different functionalities. For example, graphical user interface, user database, or web browsing. So all those things are put in the library part. And also for runtime environment, there are multiple core libraries provided by the Android through APIs. So in Android runtime environment, it also provides Dalvik virtual machine. So if you have done some Android programming, you will know that Android uses Java. So however, it is not the general Java. It uses the customized Java, which provides the customized API there. So you cannot find those API from the standard Java virtual environment. And that is why you cannot run the Android program on normal Java virtual machine because it did not provide the customized API there. So you can only run the Android program on Dalvik virtual machine. And above that, we have application framework and applications. So there we allow users to develop and run Android applications there. And here you can see that, so this operating system has a roughly layered structure in general, but the number of layers is quite few.